In today's class, we are going to start with problems involved in binomial coefficients. Now, as this is JEE Advanced booster class, so I can assume that you people have all done binomial coefficient problems in your binomial theorem chapter. So today we are going to think some problems which are out of the box. So let's start the class today. Here I have taken 3 problems, and all these 3 problems we know, but you will not understand actually what I want to convey through this video until and unless I simply recall 3 basic problems on binomial coefficients. That's the reason why I have taken these 3 sums. Now, for the first one, we can easily see that it is the sum of all the binomial coefficients but with alternate signs. And we all know that the value of this will be 0. I'm not going for the basics. I know that you have all covered your basics in a good fashion. Now let us see the second problem. What I have done is, I have not continued this R till 30. I have simply not written terms from 27 till 30. So I have removed 27, 28, 29, 30, 4 terms from last. And now if I ask you to find out its sum, what you will do? You will simply write that we all know, if I expand this, it is 30C0 minus 30C1, and this thing will go on. The last term will be plus 30C26. Now I cannot write this thing equals to 0 because the series is not completed. So for that I'm subtracting 30C27 plus 30C28 minus 30C29, 30C30. So these terms I have added, so I have to subtract those terms. So 30C27, 30C28, 30C29, 30C30, right? Now, for this first bracket, the sum will be 0. Therefore, our answer will be, again, calculation, I am not doing it here to save our time. This calculation is pretty simple. You can do it. It is 30C3, 30C2, 30C1, and 30C0, which is actually 1. Okay, so we can find out this sum, and the answer for this series will be this one. Now, so what is our prime motto? I have shown you, if some terms are removed from the last of the sequence, which contains your binomial coefficient, you can still find out its sum. See the last problem here. I have removed certain terms from the beginning. I have started the series from 5 and I have moved till 30. So what I will do in this case, I will add the missing terms. That is, I will write 30C0 minus 30C1 plus 30C2 minus 30C3 plus 30C4. These are the terms which are missing. So I have added these terms, and now I am writing the whole series minus 30C5 plus 30C6, and this thing goes on till 30C30. Okay. So these are the terms that I have added. So I have to subtract that. So I am subtracting this whole thing, 30C0, 30C1, 30C2, 30C3, 30C4, right? So this whole part, this part will give us 0, and our answer will be this one. Again, I am not going for the calculation. Calculation, you can do it. So what we have learned from these three problems. One is, if we are given the whole sequence with the binomial coefficients, we know that there is an alternate sign in between, so answer is 0. If you remove some sums from the beginning, still I can find out the sum of that sequence. If you remove some terms from the end of the sequence, still I can find out its sum. Now the actual twist. If the problem is given something like this, now what is that? I have removed some terms from the beginning. I have removed terms from the last. And now I have asked you to find out its sum. How to solve this one? One solution you can say, sir, let us just add first 12 terms, and then at last I will subtract those 12 terms, and at last I will add the remaining terms from 25 to 30, and then again I will subtract it. But do you think that it is a feasible solution? You think about it, here the number is 13 to 24. Suppose if I say that it is 500 CR and your R starts from say 299 till say 345, then is it possible to add the terms which are not given in the beginning and add the terms which are not given at last and then subtract it? It is not feasible. So we have to think some alternate way of doing this sum, right? So how to start this one? Look it carefully. We have all done, we all know this, which is called your Pascal's identity. In Pascal's identity, we know that the Pascal's identity says NCR plus NCR minus 1 is always equals to N plus 1 CR. Am I correct? This is our Pascal's identity. So this identity I will use here to solve this sum. Check it how I'm doing it. So the given series is 13 till 24 minus 1 whole to the power r. Now 30CR can be written as 29CR plus 29CR minus 1. Is it clear? Is this correct? Simply I have used the Pascal's identity. Now if I separate, it's minus 1 to the power r, 29CR plus minus 1 whole to the power r, 29CR minus 1. Okay? Now we can write this thing like minus 1 whole to the power r into 29CR, and I'm giving a minus sign over here and taking the exponent of minus 1 as minus 1 to the power r minus 1, 29CR minus 1. Now I can see a very interesting thing here, that if this is my FR, this is coming to F of R minus 1. So we are getting a smell of using telescopic method. Yes or no? So we will simply use the telescopic method to find out its sum. This one is bigger and this one is smaller. So for the smaller one, R will get the value 13, and for the bigger one, R will get 24. So it will be minus 1 to the power 24, 29C24, minus 1 to the power, R will get 13 here. So 13 minus 1 is 12, 29C12. Therefore, the answer will be 29C24 minus 29C12, and that will be the answer for this problem. Have you understood this? So whenever a binomial series is given and we have been given some middle terms, some initial terms and some last terms are removed from that series, all you will use is this method, which actually I have used the telescopic one. There was actually no binomial coefficients thing that I have used here, except the Pascal's identity. I have mainly used the telescopic method to solve this one. Is it clear? Okay, let me take another problem of different kind. So this question. In this question, the question is same. Only thing is that the binomial coefficient I have taken in the denominator. Now, there is a very famous identity. You must remember this. When the binomial coefficient is in the denominator, you always use this identity, that is n plus 1 over n plus 2, 1 over n plus 1 CR plus 1 over n plus 1 CR plus 1. This is a very important formula that we have to remember. Whenever you find that the binomial coefficients is in the denominator, we must use this one to solve it quickly. So in this case again, I will write this thing as 13 to 24 minus 1 whole to the power r is there. 1 over 30 CR can be written as 30 plus 1 divided by 30 plus 2, n plus 1 by n plus 2, 1 by n plus 1, that is 31 CR plus 1 by 31 CR plus 1. Now this is a constant. I can take outside our sigma sign. So it will be 31 over 32 outside. 13 till 24 minus 1 whole to the power r by 31 CR plus minus 1 whole to the power r by 31 CR plus 1. Right? Now we can write this thing like 1324 minus 1 to the power r divided by 31 CR. I'm taking a minus over here and I'm raising the power of minus 1 to plus 1, r plus 1. So that will nullify this minus sign. 31 CR plus 1, right? Now, you can observe that we are getting, if this one is a function of r, then this one will be the function of r plus 1. So naturally, again, we will use the telescopic method to find out its sum. So its sum will be, this one is the lower side, this one is the higher side. So the lower side will get 13 and the higher side will get 24. So the answer in that case will be minus 1 to the power 13 divided by 31C13 minus, this one is the higher one, so it will have the higher value, that is 24. So minus 1 to the power 25 divided by 31C25. That's it. So, little simplification will give us, let me write this thing first and this one in the second place. So, it will give us 1 over 31C25 minus 1 over 31C13. That's it. And that's your answer. Is it clear? So you see, in the last two sums that we have done, we have mainly used the telescopic method to find out the sum. There is less binomial theorem conception is used here. In the previous sum, I have used the Pascal's identity. And in this case, I have used this identity 1 by NCR is n plus 1 by n plus 2 into 1 by n plus 1 CR plus 1 by n plus 1 CR plus 1. So whenever you find that your binomial coefficient is in the denominator, we must use this identity. Okay? The rest is all about your telescopic method. So I hope you have enjoyed this class. See you tomorrow. Till then, take a very good care of yourself. Thank you so much.